Okay, so we're going to start talking about chemistry in this next series of videos. And chemistry is something that makes people get really uncomfortable. Sometimes people's eyes roll back in their head and they think, I can't do it. I used to be that way. Chemistry doesn't have to be that scary, especially the chemistry that we're doing in here. It's not really intense. So let's get into it, and hopefully I can answer a lot of the questions that you'll have about it. So the first thing that you want to know about chemistry is that it's going to be based on the principle of atoms, and that all matter is made up of atoms. So you've heard of atoms before, probably. And then if we want to get a little bit more in depth about it, this right here is a picture of an atom. So a couple of things that you want to notice is that there are three parts to it, three types of particles, subatomic particles. You have protons, neutrons, and electrons. So the protons and the neutrons are going to be right here in the center, which is called the nucleus of the atom. And then the electrons are going to be cruising around this thing called an orbital, which is around the outside of the nucleus of the atom. Another thing that you want to notice is that the protons are going to have a positive charge. The neutrons are going to have no charge, or a neutral charge, right? And then the electrons are going to have a negative charge. So that's going to come up later when we start talking about ions and those types of things and what makes them have the charges that they do. So if I ever ask you to draw me an atom, this type of thing is what I'm looking for. So you can just make sure that you have the protons and neutrons in the center and the electrons on the outside. Now, the numbers of protons, neutrons, and electrons is going to change depending on what atom I ask you to draw. Like, for instance, this is an atom of helium, but we'll get into that a little bit later. And we'll do some activities with that in class. Okay, so hopefully you have your periodic tables handy. If not, pause the video and go and grab it. And when you come back, we will talk about the periodic table and how that works. So one thing that I find to be pretty interesting is this whole periodic table and the way that it is arranged. So I think, is this where it is? Oh God, I always lose my stuff. My periodic table was just here. There it is. Okay. So the periodic table is actually going to be arranged in a certain way, and it has to do with electrons, protons, neutrons, all of those types of things. So if you look at each box in the periodic table, you should hopefully see that there's a big number at the top, then there's a symbol, then there's the name of the element, and then below that is going to be a number that usually is a decimal. Now, we're going to deal with whole numbers in class, and so we're going to round that number. So, for example, for helium up here in the upper right, that would just round to 4. And then for like fluorine right here, this number would round to 19. Right? So you can kind of keep that in mind as we talk about what we're going to be doing with the periodic table. Now, in class, hopefully you've done this or you're going to be doing this, and you can do this right now if you like. What you're going to be doing is above this column right here, you can write a Roman numeral 1, or the I. And then over here you can do a Roman numeral 2. Then you're going to skip this middle part, Roman numeral 3, 4, 5, 6, 7, and 8. Okay. Then along this side, if you want to take a pen, you can draw the regular number 1, number 2, 3, 4, 5, 6, and 7. Now, right now you're probably like, why am I doing that? Don't worry about it. We will definitely get into that in a little bit. So those numbers are going to help you to figure out how many orbitals and how many valence electrons these different atoms are going to have. So before we get into all of that, I know you're probably like, what is she talking about? Don't panic. Let's look at all of these boxes. They all look the same, right? Except they've got different components. They have the same basic parts. So this big number at the top is going to be what's called the atomic number. Then this is called the symbol. Then you've got the name of the element, and at the bottom, that's the atomic mass. So the first thing that we're going to talk about is atomic number. And so here in your notes, you can see that the atomic number is always going to be equal to the number of protons. It also usually is going to be equal to the number of electrons. Now I say usually because first we're going to start in this nice happy place where everything makes perfect sense. And then I'm going to totally break that down for you. So we're going to say it's the number of protons, it's also the number of electrons. So if we go back to our periodic table here, that's not my periodic table. How do I get there? Oh boy, I don't know what I'm doing. Okay, I'm not good with max. Okay, so if we look at our periodic table, I can say, okay, carbon. How many protons does carbon have? And all you have to do is look at this number at the top and say 6, right? So this number 6 refers to the number of protons that carbon has and also the number of electrons that it has. So carbon has 6 protons and 6 electrons. Beryllium over here has 4 protons and 4 electrons. Hydrogen, 1 proton, 1 electron. So you see a trend hopefully happening there, okay? So that's going to be atomic number. If we start talking about atomic mass gets a little bit different. Atomic mass is going to be talking about the sums of the masses of protons and neutrons. So what that means is it's the number of protons plus the number of neutrons. So if we go, oh boy, how am I going to find that periodic table? There it is. Okay, so if we look down here, this number 12 for the carbon, that is saying that's the number of protons plus the number of neutrons. Okay, so now let's think about this. I've told you that there are 3 parts of an atom: protons, electrons, and neutrons, right? Now, if you think about it, this number up here at the top tells you the number of protons, and it also tells you the number of electrons. So the one that we can't figure out yet is the number of neutrons. This number down here tells us the number of protons plus neutrons. So if this number up here tells me protons, this number down here tells me protons plus neutrons, how could we figure out the number of neutrons? Well, we can just subtract it. It's that simple. So if we take 12 minus 6, that gives us 6, and that's the number of neutrons that the atom has for carbon. Now, if we look right next door, it's not always that pretty, okay? So let's look at boron. First of all, looking at this number up here, we know that boron has 5 protons and it has 5 electrons. But if we look down here, that's going to round to 11, right? And if we take this 11 minus 5, we get 6. And that's how many neutrons boron has, okay? So a lot of people make this common mistake where they think this number up here is going to be protons, neutrons, and electrons. That is not the case. It's protons and electrons. Sometimes it might be the number of neutrons, but that's not where you're getting it from. You're getting the neutron number by subtracting these 2 numbers, the top and the bottom one. Okay, so that's going to be atomic mass. Okay, so in the next video we're going to start talking about electrons, and before I actually leave you, we're going to just briefly talk about what's called isotopes. So I believe that's Homer Simpson's team on The Simpsons. Hopefully I'm not dating myself by saying that. But anyway, isotopes, you may have heard the word, but you may not actually understand what it means. And basically what happens is atoms are going to change over time, and when they are going to have a different number of neutrons, we call them isotopes. So there's a couple of different types of isotopes. The most common one you've probably heard of is a radioactive isotope, and that's going to decay, and as it decays, it's going to give off particles and energy in the form of radiation. So we use that actually to help us for a lot of different things, right? If you think about cancer treatments and those types of things. Another way that we use it is for carbon dating. So if you were to find like a fossil and you wanted to know how old that fossil was, you could actually look at how many isotopes of carbon are in there, different types of isotopes, plug it into this formula, and then it could tell you how many years old something is. So that's a useful way that we can use isotopes as well. So in the next video, we'll start talking about electrons, and that's going to get us into the world of chemical bonding.